We're going to venture into a dark, wet crawl space, a crawl space that has obviously been wet over time and has damage to wood fiber and some attempted repair. So we're going to try to decide how damaged it is and how good the repair is. If you look closely at this 2x10 joist, you'll see that it's not a rectangle anymore, that it's thinner up here than the 1.5 inches it was cut to. That's dry rot. That means that quite a bit of the fiber from the wood is gone. Part of the protocol of a home inspection or a pest inspection is to probe the wood to see if it's soft. This looks like it would be soft, but you can see probing it, it's tougher than it looks. Now that's soft, the tool went in it, but didn't just bust right through it. And it really looks like it might have. Now we're seeing the product of some incomplete and sloppy work, where the wood from previous repairs is just left, the debris is left in the crawl space. It's in contact with the soil. That means that termites and wood-destroying insects can come right up through the soil, get right in the wood, and start infesting the house. This is something we want to avoid, and the code actually says that all debris should be cleaned out of a crawl space after construction. We're seeing evidence of wood fungus on this joist. It's not a surprise. We're in a wet environment, and fungus likes wood. And down here a little further, we're seeing what's left over from a clothes dryer being vented into the crawl space. So if you want a perfect science experiment to see how to grow fungus, start with a cool, wet crawl space, blow damp, warm air into it, and that's the result you will get. Somebody's idea about how to repair this was to re-support the joist because they were soft and not capable of carrying much load anymore. So that girder beam is probably original to the house. These two have been added. We know by probing underneath that they're setting on mud. There's no concrete underneath them. It's not a frost-proof foundation. It's not suitable bearing. And these clay expansive soils will swell when they get wet and shrink when they get dry. So these supports are going to go up and down. They're going to push the house up and down, probably make the situation worse. The house isn't falling in, but it's moving up and down, and that's going to be hard on the structure. Then we can get right up here where the joist sits on the girder beam, and we see that the joist is so weak. There's another one right there, that the girder beam, this makeshift girder beam, is actually digging into the joist. We're back in the northwest corner of the crawl space. This is probably a place they used to pump water out of the crawl space. You see there's no sump, there's no container, but there's a hole that's been dug. It looks like it's even brick lined perhaps. So probably there was a pump in there at one time. You can see how high the water table is, that the water is standing about 10 or 12 inches from the surface. Nice clear water, it's groundwater. If you dig a hole 10 or 12 inches deep, that's what you're going to get. There is a sump and a sump pit on the other side of the crawl space. The reason this water isn't gone is that the soils are clay, water doesn't readily flow through them, and then if you can dig individual pockets and they'll have individual amounts of water in them. Now we're back further into the corner, the northwest corner, and we're going to progress a bit. First we're going to look at clear wood fungal marks. This is deterioration of the wood. Some repair that doubled up a joist some time ago. Then we're going to move further in. I'm crawling, so it's not very smooth. And we see very clear mold growth. So this is active mold. We don't know what kind. We'd have to test for it to see. But that's what's going on here. And here we see powder post beetle. That little powdery mark and small hole about the size of a pencil lead is where powder post has bored into the wood, deposited larvae where they will eat the wood when they hatch and further deteriorate the wood fiber. An interesting miscellaneous find, an old bottle of some kind. Perhaps that helped the carpenters build the house in the first place. I'm going to get a little closer look now at how the joists are failing where the new girder has been pushed up against it. We're well back into the east end of the house now. We were hoping we might find some better conditions. Unfortunately, the conditions are pretty uniform. The wood is wet, it's dark, it's been wet over a long period of time. The main girder beam shows some bobble in its configuration, a sag there. The opposite reaction to the sag, the kick up at the end of the girder there, so contributing to unlevel floors. And here we see what we really don't want to see. This is a joist that's completely failed by fungal deterioration. We could say dry rot. Not much there holding the house up. Then we're going to find the sump pump. You can see it's installed in a pretty nice deep sump, and it has been working, and it's pumping the water outside. It was draining back into the house, but we extended the drain pipe away. Now it seems to be moving away from the house better, and we are making progress drying up the house. So what we've seen in this crawl space may look extreme, and it is pretty severely damaged for compared to what we often see. But all the common ingredients of problem crawl spaces are here. It's mostly moisture. If there wasn't a moisture problem in that crawl space, we wouldn't have rot, deterioration, wood fungus, powder post beetle. All those things are directly related to the high moisture level. So a house built a number of years ago, and water got in the crawl space. They didn't actively pump the water out, I guess, and the correct ventilation and vapor barrier were not in place to help keep the crawl space dry. It's impossible in lots of Midwestern crawl spaces to prevent water from ever entering the crawl space. So it's a different management strategy than that. We know we'll get water in crawl spaces, so we have to get it out. If a crawl space isn't naturally drained and very well drained, then a sump pit, sump pump need to be added to pump water out. We always need to cover the soil with vapor barrier. Code likes 6mm poly film or heavier, and we want to cover all of the soil so that soil gases and moisture don't come up from the soil, get in the crawl space, and make moisture problems. We don't want to insulate the floor. We saw that in this subject house, and the insulated floor causes the moisture problem to get worse, and it absorbs the moisture and holds it up against the wood framing to cause damage to the house. So if you have a crawl space, you're looking at a house that has a crawl space, the number one thing to look for is indications of long-term moisture. If there is an indication of long-term moisture, we need to look at it to see if the correct provisions have been installed to fix the problem. If not, we need to see if there's collateral damage to this moisture problem. But if you have high level of moisture in a crawl space, you're going to have damage over time. It's not a question of if, it's a question of when.